This lab is on the configuration of Enhanced Interior Gateway Routing Protocol or EIGRP for sharing of routing information between R1, ISP and R3, and at the same time we're going to make use of access list to implement some security restriction between the access of devices. Let's start off with configuration of some basic configuration as can be seen from A to G. Let's use the simple method of just creating a sample script in order to configure the requirement that's given. Similarly to what we have done before, disable DNS lookup will be no IP domain dash lookup exclamation mark, configure device name which is host name. In this case, let's start off with R1. Configure a private executive mode password of class, enable secret class exclamation mark. Okay, for serial interface that require a clock of 128,000, we'll do it later when we configure the interface. Assign Cisco as the console password, line console 0 exclamation mark password Cisco exclamation mark login exclamation mark. Okay, assign Cisco as the VTY password, line VTY 0 spacebar 4 password Cisco exclamation mark login. Okay, enable telnet access, okay, which is basically just doing a login under the VTY. Okay, and that will be the basic default configuration that we need to do on router R1. Okay, Control A, Control C. Okay, let's go to R1. Okay, go to config T, paste. Okay, and we have configuration for R1. Go to ISP, change the host name to ISP, Control A, Control C. Go to ISP, enable config T, paste. We have a basic configuration for ISP. R3, similarly, Control A, Control C, change the host name. Go to R3, enable config T, paste, and that's what we have for R3. For S1 and S3, take note that we are supposed to configure the default gateway on the switch. Okay, so we need to include additional command of IP default gateway followed by a default gateway that is given. In this case for S1 will be 192.168.10.1 exclamation mark, change the host name to S1. VTY, remember change it to 015. Control A, Control C, go to S1, CLI, enable config T, paste. Same thing, let's do it for S3. Host name change to S3. Default gateway in this case will be .30. Okay, the rest all the same. Control A, Control C, go to S3, enable config T, paste. And we've done all the basic configuration for R1, R3, ISP, S1 and S3. Next we'll be basically doing the IP address on all the various devices. In order to make the configuration faster, I've already configured ISP, R3, S3 and PCC, but I will be doing a demo on how to configure the IP address on the various interface, starting with R1. Okay, so we can see that from the table, we start out with gigabit interface 0/1, IP address which is 192.168.10.1, 255.255.255.0 which is /24. Do a no shut to enable the interface. You can see that it becomes green. Interface LO0, the loopback interface 0. IP at 192.168.20.1, 255.255.255.0 for /24 again. Okay, do a no shut to double confirm that it's enabled. Interface S0/0/0. IP address 10.1.1.1, 255.255.255.252 with /30. Okay, remember to do your clock rate, as this is the DCE side of the serial interface, and we're going to set it as 128,000. Do a no shut to up the interface, and that's it. The 3 interface on the router has been configured. Okay, let's go to the switch, because we need to configure an IP address on VLAN 1. Interface VLAN 1, IP address 192.168.10.11, 255.255.255.0. Do a no shut to double confirm that is enabled. And last but not least, for PCA, configure IP address as given will be 192.168.10.3. Default subnet mask 2525.25.0, and gateway will be 192.168.10.1. Okay, and that's it. We have configured all the addresses on all the various interfaces. As I mentioned, I have included and configured the IP address on ISP, R3 and SW3. Next, we will need to actually configure the EIGRP configuration on R1, R3 and ISP to share what they actually know about each other, so that in this case they are able to access each other network before we start to actually configure the security implementation. So let's start out by R1. Okay. Similarly to how we configure RIP version 2 and OSPF version 2, we start out by doing router EIGRP. Okay, in this case for EIGRP, we actually need to specify the autonomous system number, which is the AS number, and in this case you can see it from the top, we actually given it as 10. Okay, so this number will always be given to you, and we need to make sure that this number is same throughout all the routers that is supposed to communicating within the group, so that they know that they belongs to the same group. So router EIGRP 10, always remember to do a no auto summary, okay, as a default, to enable that they won't auto summarize the addresses. Okay, so as what we have done for RIP version 2 OSPF, always make use of show IP route to enable us to do our network command. So the first network we're going to include will be 10.1.1.0. Similarly to what we have configured for OSPF, we are going to make use of the wildcard mask, which is the inverse of subnet mask, to specify more clearly what is the range of addresses that the router are supposed to be communicating. And in this case for /30 will be 0.0.0.3, and for network, next one 192.168.10.0, wildcard mask will be 0.0.0.255, and the last network that we're going to enable communication with 192.168.20.0. Same thing, /24 will be 0.0.0.0.255. That's it, we have actually enabled EIGRP on R1. Let's go on to ISP. Router EIGRP 10, the AS number, which must be the same. No auto summary. No auto summary. Okay, and next do show IP route. Okay, so we have 3C again, so network 10.1.1.0.0.0.0.3 for /30. You can see that actually one of the network actually up. That means that R1 actually is communicating, has established a neighbor or adjacency with ISP. Next will be 10.2.2.0 /30 again 0.0.0.3. And the last network that we're going to enable communication will be 209.165.200.224. In this case is /27, so it will be 0.0.0.31, okay, which is the wildcard mask for /27. Okay, and that's it, the 3 network has been configured. And last but not least, R3. Router EIGRP again 10. No auto summary, and do show IP route. Okay, network 10.2.2.0.0.0.3 for /30. Network 192.168.30.0.0.0.0.255, and last but not least, network 192.168.40.0.0.0.255 / again. Enter. Okay. So how do we verify? We can do a show run to make sure that all configurations are intact. You can see that we have configured the router EIGRP. Okay, do show IP route again to make sure that the route has been shared between all the routers. You can see that for EIGRP, basically the code that signifies the sharing of routing information from other router is signified by D. D represents EIGRP. The admin distance is 90, as has been mentioned before. So now we have actually successfully configured EIGRP on all the routers, so that all the routers actually know about each other network. So next we'll be going on to configure the next portion, which is to create access list or implement security according to the requirement given. So I can see from option I, we are supposed to create a standard number access list that allow traffic from all hosts on 192.168.10 and all hosts on 192.168.20 to access all hosts on the 192.30 network. So basically we're going to allow the 10 network and the 20 network, the loopback interface on R1, to be able to access the 192.30 network. In this case, we're going to basically just specify that we are going to allow them to ping each other. Okay. So how to do it? Basically very simple. Always remember for standard access list, because we are only going to specify the source address, that means that where the address is coming from. So it's a good practice to always place the access list, okay, towards the destination router. So in this case, my R1 is the source, so my destination is my R3. So in this case, we're going to do it, the access list on R3. So how to do it? The command is basically very simple. Access list, okay, and we're going to make use of the number 1. As you can see that we are going to make use of a standard number access list. So we're going to make use of 1. We can actually make a remark, okay, basically to allow R1 LAN access, okay, is to let us know about what does the access list do on R3. Same thing, access list again, 1. Okay, so in this case, we're going to permit who? Permit the 192.168.10.0 network. For access list, the extra parameter that going to specify the part of the address or the subnet address is still the same as what we've done for OSPF and EIGRP, which in this case is the wildcard mask. So a /24 network will be equivalent to 250.0.0.255. Okay, same thing as mentioned in the requirement. We are also going to allow, which is permit 192.168.20 network to be able to access 192.168.30 network that R3 is connected to. The subnet mask is still /24, so it's 0.0.0.255 for the wildcard mask. Enter. Okay. And if you look at the lab, okay, we are supposed to deny all other traffic other than .10.20 network. So in this case, we are supposed to have the last requirement, which is to deny any other address from being able to access the 192.168.30 network. Enter. Okay. So after that, we have configured the access list. Because a router have more than one interface, we need to make this specified on the router. Which interface are we going to apply this security implementation? And in this case, okay, we're going to apply on G0/1, so that any traffic that try to go through 0/1, okay, the router basically will check whether what is the access list that we have configured. So interface 0/1, okay, the command is basically AP access group. Okay, in this case, just now we have numbered our access list as 1, so the access group will be 1. Okay, and we're going to tell the router any traffic that is going out of the interface 0/1 out, in this case out, we're going to ask it to check whether the source address is it 192.168.10, the source address is it 192.168.20. If it is, then we will permit or allow it to go through. All other traffic, basically, we will not allow it to go through. Okay, so enter. How to verify? You can basically just show access list to show access list. Okay, you can see that this is the access list that we have configured. Okay, other than this, we can also do a show IP interface. Okay, to take note of the access list has been configured. So you can see that we have actually enabled a outgoing access list on the interface G0/1, which is the interface access list number 1. Okay, so let's just verify whether we can ping to each other. So this is the 192.168.10 network. So definitely we'll be able to ping to 30.3, which is PCC network. Wait a while for the ping. Okay, you can see that we're successfully be able to ping. Let's simulate a ping on ISP which doesn't belongs to 192.168.10 or 20 network to a ping 192.168.30.3. Okay, you can see that is U means that it's unreachable. That means that our access list has been successfully created, prohibiting any other traffic other than 192.168.10 and 192.168.20 network from accessing 192.168.30. Okay. So next, let's go on to the next one, which is to create a name standard access list that conform to the following policy. So in this case now, we're going to allow traffic from all hosts on the 192.168.40 network to access all hosts on the 192.168.10 network. So in this case, we're going to allow the network from R3 to access the network on R10. So now it basically is the reverse flow. Just now 10 is the source, 30 is the destination. Now 40 is the source, 10 is the destination. But the difference now is we are going to create a name access list and not only a number. That means that we're going to give the access list a name now. And as can be seen that we're going to name the access list as branch-office-policy. So as we mentioned previously, a standard access list only take note of the source address. So it's a good practice to basically implement the standard access list on the destination part of the router. And in this case, we're going to go over to R1 and implement the access list here. Okay, so basically how do we do it? Okay, instead of starting the command with access list, which is a number access list, because now we're going to name it, the command basically to name it is basically IP access list. Then we need to specify that this is a standard access list, followed by the name that is given to you, which is branch office, followed by policy. Okay, so double confirm IP access list standard branch office policy. Enter. So as can be mentioned, we're going to permit the 192.168.40.0 network. Okay, because of the fact that subnet mask is /24, so the wildcard mask will be 0.0.0.0.0.255. Okay, enter. Okay, that will be the first requirement. Okay, 40 to access 10. Okay, and also allow only PECC access to the 192.168.10 network. That means that we're going to allow only one addresses, which is 192.168.30.3 to access the 10 network. So basically, we're going to permit 192.168. We're going to permit only one host to be able to reach here. Okay, so the shortcut to specify just a single IP address will be 192.1 host. The code word is host, followed by 192.168.30.3, which is the IP address of PCC. So basically, host is equivalent to basically just specifying 192.168.30.3 255.255.255.255, which is a /32. Okay, which is a 0.0.0.0, which is a /32 subnet mask. Okay, so let's just make use of the host 192.168.30.3. Okay, enter, and that's it. You have created a name access list. Okay, so we need to implement this access list on the interface. Similarly, we're going to implement it on the interface G0/1 to tell the router to check any traffic going out of G0/1 to shoot the permit statement. Okay, so IP access group and followed by the name BRANCHOFFICE, followed by policy. Make sure that you spell it correctly. Okay, and we're going to tell the router to check for the outgoing traffic, which is out. Okay, so this is how we implement it. Okay, do a show access list. Okay, you can see that we've implemented a standard access list with a name, branch, office, policy. Okay, we're going to permit the 40 network and the 30.3 host IP addresses. Okay, basically this is how we actually implement a name access list. Okay, so you'll be asking me if we need to modify the standard access list, because for option K, you can see that management has decided that user now from the 209.165.200.224/27 network should be allowed full access to the 192.168.10 network, because previously when we did that configuration, we didn't allow, because we only allowed .40 network and the .30.3 PCC to access. That means that the 209.165 network will not be able to access the .10 network. And at the same time, we didn't follow the implementation of a deny any at the end of all access lists. So we're going to make use of the number access list to actually implement, okay, the additional requirement. You can see that currently only have the number 10, which is the first statement, 192.168.40, 20 will be to permit the host. So to do it, same thing, we need to go back to the access list, standard. Okay, in this case, branch, office, policy. Make sure it's spelled correctly. Enter. So since we have already 10 and 20, we're going to insert the next two statements as, okay, line 30, permit 209.165.200.224 0.0.0.31, which is the wildcard mask for /27, and 40 to deny any, similar to what we have done for R3 where we're talking about traffic from R1 to R3. Enter. Okay, that's it. Do a show access list. Okay, and we can see the additional two statements that has been implemented on the name access list branch office policy. So basically, number access list will allow us to insert any permit or deny statement in between any requirement if there's a need for us to make changes to the access list, rather than deleting the whole access list and to rekey in every access right again. So basically, this is how we actually implement access list, and at the same time to enable EIGRP on simple networks such as R1, ISP, and R3.